Alright, welcome to another video on set. We're gonna be solving set problems like very directly, and you're going to be understanding how to apply all the set theories we've discussed. We're going to be applying complements of the set. Be applying union, intersection. We'll just be seeing um, the meaning of those things with real problems. This is a problem that says if u equal u actually here means the universal set. Okay, so I think I explained that in the last video on the symbol for universal set. Now u is SPLENDOUR, and the set x is SPEND, and the set y is SENOU, and z is PNOUR. Now they say find y complement. Now, if you're able to recognize that this is actually y complement, then you've gotten a little bit better in set, at least. So, next thing is what is y complement? What is a complement of a set? If you go back to what we discussed, we said that the complement of a set is any element in the universal set that is not a member of the set that you're working on. So we have y here, and we have the universal set. So all we just need to do is to bring out what is in universal set that is not y, that does not belong to y. Now, if you check it very correctly, you will agree with me that y complement. If we cancel out things in the universal set, or we bring out things that is in universal set that's not in y. And notice that s is in the universal set and also in y, so we are not bringing it out as a complement. Um, P is in the universal set, but not in Y. So basically, is a complement of Y. Now, L is in the universal set, but not in Y. So L also is a complement of Y. Now, E is in the universal set and also in Y. So it's not a complement. What about N? It's here and also here, so it's not. D is in the universal, but not in Y. So D we can say is a complement. What about O in the is in Y, but also, yeah, it is in the universal, so it's not a complement. U is in the universal, also in Y, so it's not a complement. And what about R? R is in the universal, but not in Y, so R is a complement. So at the end of the day, our answer for Y complement, which are the elements in the universal but not in Y, is PLDR. All right, PLDR. So that is the complement of y. Now, what about b? They're asking us to find, um, let me put it this way. They want us to find x. Now, when they write something like this, what does it mean? If you remember the last, when we discussed set notation, this means intersection. Now, intersection means common elements, okay? So that's just a reminder. Now, brackets, the y complement, which we just found, um, union, that is the symbol for union, z. This is what they want us to find, and we do not know this. So, how would we find this? I would advise that you start with the bracket first. You already know that y complement is PLDR, so you may want to list it out. Um, you may want to list it out as uh, y complement is PLDR, right? Z is what? P, see here, N O U R, all right? So when you say Y complement union Z, what does that mean? We explained that union means combination. So bringing together or the marriage of two sets. So we're merging these two sets together um, as a union. When we bring them together, Y um, complement union Z will be equal to, um, when we merge them together, take note, you're not going to repeat um, same elements in the two sets. So we're not going to write PP. We're just going to write P because it appears in both of them. So it's a common value. Then we have L, we have D, R, then we have N, O, I think U. All right. So if we merge two of them together, you see we started with P, L, D, R, right? Then we're not repeating P again in Z. We just brought out N, then O, then U, and we're not repeating R again because we already have it here. So this is Y complement union Z. This is it here. P L D R N O U. Now take note. We're not sure. We just worked on the brackets. We still have this part, X intersection this we just got. So if we put it in a new page here, um, let me get the value of X. X is SPEND. So we have X as SPEND. All right. Now we have Y complement union Z as what? Let me get it. As PLDR NOU. So we have it as PLDR NOU. So now, um, what is the intersection? Remember what we're looking for. Remember what we're looking for is X intersection this Y complement union Z. And we know that intersection means the common element. So they're asking us what is common between these two sets, this one and this one. So check it out. You see P is here, P is here. So we'll say P is common. Now let's see. E is not in both of them. N is okay. Yes, N is in both of them. So we have N. Yeah, N is here, N is here. So that's common. Then D is not in both of them. So okay, D is in both of them. D is here and D is here. All right. So we have P and D. Okay. So at the end of the day, the answer to our question is P and D. Um, these are the common elements in X and in the union of the complement of Y and Z. So if you uh, solved and got this, possibly this is your answer. And that is how you are able to solve your first problem in set notation. Now let's work on another problem. So what I want you to do is look at this problem, try it out, pause the video, try it out, then come back and see the answer. Okay? So hoping you have tried it out. The question says if the universal set, which is U, is 1, 2, 3, 4, 5, 6, P is 3, 4, 5, Q is 2, 4, 6, and R is 1, 2, 3, 4, list the elements of P union Q complement. Take note of that. If you didn't see that, please, it's complement, then intersection R. Now, I explained very carefully that you should always start with a bracket, right? Now, P is 3, 4, 5, right? Q is 2, 4, and 6, right? Now, P union Q, which is inside the bracket, is what? What is union? The union is the combination of two or more sets. So the combination of these P and the set P and Q is going to be, let's start with 2. Yeah, 2, 3, 4, 5, and 6. So I just arranged it orderly. You would have started with 3, 4, 5, then 2, 6. For arranging it orderly, you get 2, 3, 4, 5, 6. Right? So it works like that. So that's the union. So you see every element in this this P and Q appears in what we just brought out. But take note that the question wants us to find P union Q complement. So what is the complement of this that we just got? So if we have to bring it out now, what we say is P union Q. We've gotten P union Q, but this time the complement. So what is complement? Complement is any element in the universal set that is not in the set you're working on. So look at the universal set. We've gotten already P union Q, right? But we need the complement. So in the universal set, we have one there that is not here. So that is a complement. All right. So check it again. 2 is in the universal, 2 is in the union here. So it's not a complement. 3 is there, 3 is here, it's not a complement. 4 is there, 4 is here, it's not a complement. 5 is there, 5 is here, it's not a complement. 6 there, 6 here, it's not a complement. So the only complement we have is 1. So you just see like it's something that is not anything that is not P union Q or not this. That is 1. And it has to be in the universal. And that's how you know a complement. So I think you should by now you should understand what complement is. So we've gotten this first part here, P union Q complement. But remember, the question says directly that we need to find P union Q complement intersection. Remember that symbol? Intersection R. All right. Now, what is R? R is 1, 2, 3, and 4. We already know that P union Q complement is this, right? 1. Now, intersection R, it means that we need to know the common element between the complement of P union Q and R here, the set R. So what is common between P union Q complement and R? What's the answer? 1. If you check it, 1 is here, 1 is here. So the answer to this question, we'll just say is equal to 1. That would be the answer to the question. So at the end of the day, we just worked on another set problem. And we see that all you need to know is the particular set. If you're able to identify the universal and bring out all the other sets, arrange them, know what you're looking for. We started with P union Q, start with the brackets always. Then we noticed that there was a complement there. So we, after finding P union Q, we got a complement. And then remainder was to find the intersection or the common element with R. And we just found it out that it is 1. And this you see here is the answer, 1. That's how it works. Okay, now let's work on, let's see if it's the last one. It should be the last one. I pray it is the last one. But let's see. Now this is another one. So try this one out. I'm going to give you a clue a little bit because I've not discussed anything on this P minus Q. So I'm going to tell you that it means removing any value of Q from P. That is P minus Q. But you can say pause the video, try it out, and see if you get the correct answer. So let's assume that you've done that. You've come back to the video. The question says let P be 1, 2 U V W X and Q be 2, 3 U V W 5, 6 Y and R be 2, 3, 4 V X Y. Determine P minus Q in parentheses intersection R. So as usual, we're going to start with the um, bracket here. So P, we already know is 1, 2, U, V, W, and X, right? And we know that Q is 2, 3, U, V. My U looks like my V, okay. Then W, 5, 6, and Y. So what is P minus Q? Now P minus Q is something like a complement that we've been working on. Something like that. So basically, if you are working on something like this, what you need to do is this. you're going to remove the values, any element of Q from this, from P, any element of Q from P. So you just look at P directly and just subtract. So like subtract anything that is Q from it. And at the end of the day, you're not merging P and Q from after your subtraction. You're just bringing out the remnant or the remaining elements in P. That would be your P minus Q. So if you check it very clearly, 2 is here and 2 is here. So we'll subtract this one. Um, U is here and U is here. So it means that it's an element of Q. So we have to, sorry, let me go back on that. So we have to subtract it from P. V is here. So we have to subtract it from P. W also uh, is a member of Q. So we have to subtract it from P. There's nothing else left um, of Q. So what we have left after subtracting elements of Q from P is just 1 and X. So take note, we're not merging the remnants for Q along with it. We just want to subtract any element of Q from P. So at the end of the day, our P minus Q will be the remnants um, after removing the elements of Q from P. And that is just 1 and X. Okay? I just want that to sink in a little bit. Just allow it sink in. So now we're not sure. We need to get intersection R. So the original question is P minus Q intersection R. What is intersection? Intersection is common elements. And we know R is 2, 3, 4, V, X, and Y. So if you're following very closely, you'd already know the answer to this question. We already know that P minus X is P minus X, I mean, P minus Q, sorry, is 1 and X. So what is the intersection between these two, P minus Q and R? That is, what is the common element between these two? So the common element is just X. So at the end of the day, we can say that P minus Q intersection R is equal to X. And this you see here is your answer. So you can just put it this way. This is your answer, X. Okay, so I think you've gotten the idea of what P minus Q is. Um, if at all, that is what you should get. Mainly, I think that's why I put this example here so that you get the idea of what P minus Q is or anything related to that kind of example. Now let's work on something else. How many subsets will a set containing 5 elements have? Wow, it's a big one. Now, can you remember any question like this we've treated if you watched any of our videos before on set? This is a question on power set. What did we say power set is? It's a set that has all subsets of a particular set. So you just list out all subsets of a particular set. You're able to tell that, okay, yeah, this is a subset of this, this is a subset of this. You just tell you the different subsets of a particular set. So, but this time they want to know how many subsets can you get from 5 elements. So let's say the set has um, a set X has 5 elements, maybe 1, 2, 3, and 4, and 5. How many subsets can you get from this? But we already have a formula for power sets, which is 2 raised power s, where s is the number of elements. So we don't have to go through all of this. We just have to put our value 2 raised to power 5, which is the number of elements in this case. Let me use another color to distinguish this. So it will be 2 raised to power 5 in this case. And we know that 2 raised to power 5 is 32. And that is going to be the answer to this question. How many subsets will a set containing 5 elements have? It will have 32 subsets. Okay, subsets. Okay, so that's how it works. But you can also try to see if you can list out the possible subsets, assuming these are the This is the set, and this is the elements in this the set. Can you list out the 32 subsets? I think I've taught that before in the other videos. If you can try it out. Let's work on a last question, possibly. Now, this question is a very interesting question. I gave this to my students, and well, some of them tried. At least they did well. Um, well, let's see. The universal set is this: 5811 dot 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 23. Anytime you see something like this, and they give the preceding number, and then they put dot 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 and give the final number, they want you to fill in those numbers, like fill in those dots. um, Find the sequence and try to fill it up. That's what they want you to do. So we're going to start with that before we read the entire question. We need to know exactly what the universal set is before we, because the universal set is 5, 8, 11, dot, 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 23. So U is 5, 8, 11. Now, take note of the sequence. The pattern here is that after 5, if you add 3, you're going to get 8. If you add 3 again to 8, you're going to get 11. So basically, it's just x plus 3. So it's then you add 3 again to 11, you get 14. Add 3 again to 14, you get what? 17. Add 3 again to 17, you get 20. Add 3 again to 20, you get 23. So you see, we're able to get the pattern. And we have our complete universal set. All right. So this will really help you if you're able to follow the pattern and get it right. It will really help you because the preceding questions will actually um, affect you if you do not know the universal set correctly. All right. Now let's continue the question. They say k is x, where x is less than equal to 12. So anytime you see something like this, x dot dot x, this means x where x is. All right. Or it can also be written as this can also be written as x slash x. So it's the same thing. X where x is. Yeah, that's what it means. So now let me clean that. So you've understood that part. Now x where x k is x where x is less than and equal to 12. So this means that all the values less than 12 and 12 is the value for the set k. That's what this part here. But we're not sure. F is a set where you say an F is a set uh, where x is a prime number. F is x where x is a prime number. Uh, Now we're talking about all the prime numbers. Uh, all the prime numbers. Now, what we have a lot of prime numbers, but how we know the prime numbers we're talking about? That is where this next part comes in. This next part is very crucial because it tells you that you should not list all the prime numbers you know because you're telling you now that x is an element of u. Remember that when I talked about set notations, I wrote something like this once. This means x is an element of u. Meaning the universal set. It could be any type of set, but they're just telling you that all this x they're talking about here must be inside this universal set. So it must contain all these numbers here. The x must contain the numbers in the universal set. So we're not going to list all the numbers less than 12 for k, set k. We're not going to list all the prime numbers possible. So anything we're selecting must be from the universal set. That's just the meaning. But what we're looking for basically is x prime, x complement, intersection f. All right, now let's get the values of x first. I mean, values of k first. Did I say x prime intersection f? K prime intersection f. Okay, so I've said there's a lot of x's affected. Now k is x where x is less than or equal to 12. If you understand range a little bit, you understand that we're talking about all the values less than 12. And since x is an element of the universal, so we're speaking from here. So all the values less than 12 are in the universal 5, 8, 11, and they say less than 12 and equal to 12. But we do not have 12 here, so we're not listing 12 out in the universal. So k is just 5, 8, 11. Now, what is k prime or k complement? Because that's part of what we're asked to find. Now, k prime has to be um, anything in the universal that is not k. So if you check it out, if we cancel out everything in the universal that is not k, we're left with 14, 17, 20, and 23. So k prime is 14, 17, 20, and 23. So we know k prime, we know f. Okay, now what they say f is a prime number. Okay, so let me clean this off. So if we list out what f is, um, and they said x must be uh, f is x, where x is a prime number, and x must be an element of the universal set. So we're going to bring out the prime numbers from the universal set as our set of f. So prime number here we have 5, we have 11, 17, and 23. So we have 5, 11, 17, 23. This is the set for f. So we now know k prime, which is k complement, and f. But what we need now is k complement intersection. Let me put that well. Intersection f. We do not know this. So what is intersection? Intersection is the common element. So what is the common element between the k complement and f? And check it out. You see, I noticed first 17 is in both of them, then 23 is in both of them. So rightfully, we can just say that the common element is 17 and 23. 23. That is the answer. So this would be the answer to this question. 17 and 23. That's all. So we've almost 30 minutes of set notation problems. If you have any question, please still ask. If you have any set notation problems you want me to solve, please leave a comment down below and we'll work on them. If you like the explanation, you can subscribe to get more videos and more explanation like this.